Hello, my name is Barry Olson. I'm with the Cost Analysis Department, and I'm here today to give you a presentation on the profit maximizing quantity and price for Oil Company X's project considering increased capacities at its existing facilities. The presentation has the following sections: this introduction with purpose, cost analysis data, total cost, average and marginal cost, profit maximizing, and a conclusion. As you know, Oil Company X is a large oil refinery, and it's been expanding and taking on new projects, which has included a project considering building a pipeline that stretches across the U.S. An alternative investment that they're considering is increasing production at its existing facilities. So the purpose of this presentation is to present the profit maximizing quantity and price if production continues at those existing facilities. Some important nomenclature to understand and variables that were used are shown below with their respective acronyms: price, quantity, total revenue, fixed cost, variable cost, the average total cost, the average fixed cost, the average variable cost, marginal cost, and profit and loss. All of these are in millions, including the quantity. The others are millions of dollars. So you can see those columns with the acronyms. And if you're not sure and can't remember, just refer back to the previous slide, and you can see what those acronyms stand for. In the middle of the table 1, there's a highlighted row. This will be important, and we'll be referring back to data that's in this row throughout the rest of this presentation. This highlighted row is important because it's the point at which the marginal revenue, you can see that column, and has a red box over a number 1.73 million. So the marginal revenue, when that equals the marginal cost, which is over near the right side of the table, both of those are 1.73 million. When those two curves intersect and when they match and are equal, the profit is maximized, and that profit maximization price is $1.73 million. And let's remember that because we'll be referring back to that a lot. You can also see that this happens at a quantity of 5 million, because everything's in millions, and the profit is 4.78 million. So let's remember that, and we'll refer back to this as we go through the presentation. So the total cost has 3 cost curves: total cost, fixed cost, and variable cost. And you can see this graphic below in figure 1. And it's important to note that on the far bottom left corner there, at 0 production levels, the only costs incurred are those of fixed costs. So at that point, the total cost is equal to the fixed cost. Then as production levels increase, you can see the variable cost becoming a factor, and it's a pretty high sloped upward curve, and the total cost goes up, continuously going up as production levels increase. And this is important because this will influence many of the other variables that show what happens to our costs as production goes up. This next graph, figure 2, is the average and marginal cost graph. These curves are shown below in figure 2, and it's important to note that that kind of goldenrod curve, the marginal cost, this one increases significantly as production increases. So as the quantity goes up, the marginal cost goes up. And this is also important, just like we saw in the previous graph with the total cost going up. That'll influence our profitability and our maximum profit. So this next graph is the profit maximizing graph, and this is really important to the purpose of this presentation. This is shown in the graphic in figure 3 below here, and the profit is maximized when the marginal cost is equal to the marginal revenue. Those two curves are on here, and you can see the marginal cost in the orange colored curve and the marginal revenue in the downward sloping blue curve. The dotted lines, both horizontal and vertical, show the point where those two curves intersect. They intersect where the quantity is equal to 5 million and the price is equal to 1.73 million. And I've noted that in a box to the right of those curves. This formula, when the marginal revenue equals the marginal cost, is important. That is the point where profit is maximized. And again, reiterating, the profit maximization price is 1.73 million at a quantity of 5 million. And remembering the table we referred to earlier, table 1, that horizontal row that was highlighted in yellow shows where the marginal cost is equal to the marginal revenue and those other data points that are happening at a 5 million quantity and a 1.73 million profit maximization price. In conclusion, it's important to remember that the profit maximization price is 1.73 million US dollars. This happens when the marginal revenue equals the marginal cost. Similarly, the quantity of 5 million happens when the marginal revenue equals the marginal cost. So that's that intersection of those two curves. Those can both be seen in figure 3. The firm is profitable at production levels below 5 million. The maximized profit at that equilibrium point is 4.78 million. And when you look back at the table, you'll easily see that at the production levels above that, that profit drops below 4.78 million. And it keeps dropping as we're incurring losses at that point, and it'll decrease to the point where the profit is negative. And you can see that on the table. These losses are important to note, that if we exceed 5 million in quantity, we're going to see a decrease in profits and we'll be incurring losses. Another thing to conclude and remember, when the marginal cost is greater than the marginal revenue, we're incurring losses. The firm should consider shutdown. That's the end of this presentation. I hope this has answered your questions about what the profit maximized price is and the profit maximized quantity. Thank you.